Hi, let's take a look at a couple of the problems that have been coming up on the Evaluate test that have to do with this essential standard for us in 5th grade, NBT A7. The problems that the kids have seen there have looked like this: 12 and 2/10 times 8/10. We have not explicitly worked on this skill very much. So if you were wondering, why can't my kids show that they can multiply? This might be why. They're being asked to multiply with decimals in a way that we haven't practiced with a lot. So let's take a look at a simpler problem like 6 times 5/10 to relate back to what they learned in Unit 4 and how we can relate that to this kind of multiplying. So if I'm looking at 6 times 5/10, I know I can actually think of this as 6 times 1/2. Half of 6 is 3. All right, kids get that part. Now, if we look at this though, just as the numbers 6 and 5/10, here's another way we could look at it that helps them understand more complex numbers. It would be a lot easier if I could just take 6 times 5. I know what that is. How can I do 6 times 5 and relate it back with this decimal? So let's take a look at our place value chart. So if I'm looking at a place value chart and I place 5/10 on here, it would be a lot easier if I could make it a 5 to work with. If I move this 5/10 over to the ones place, I have moved it one place on our place value chart. We know that every place we move to the left on a place value chart, we are multiplying by 10. And every place we move to the right on a place value chart, we are dividing by 10. So if I move this and look at it as a 5, I am multiplying by 10. So to get back to my answer in the end, I'm going to need to do the opposite. I'm going to need to move my answer back over and divide by 10. So a way we could write this would be 6 times 5, then I'm going to need to divide by 10 to get back where I need to be. So first I'm going to multiply 6 times 5 to get 30, and when I divide by 10, I get back to 3. My answer matches up. It is indeed the same. Here's how I would show it on that same place value chart. My answer of 6 times 5 was 30. So when I divide by 10, when I move everything back one place, I am at 3.0, 3 and no tenths, and that's my answer. Okay, this will help us when we get to more complex problems like 12 and 2/10 times 8/10. So it would be a lot easier if I could look at this as whole numbers. So let's put both of those numbers on our place value chart just to make sure we understand. So if I have 12 and 2/10, let's get rid of these markings here. Okay, we had 12 and 2/10. And if I want to make it a whole number, I just have one place in the one digit in a decimal place. So I just really need to move over one place to make this 122. So I've done a times 10 so far. My other number was 8/10. Again, I'm only 1/10. I'm only in the tenths place, so I just need to move over one place to make it the whole number 8. So I had to multiply by 10 twice. I had to multiply by 100 to make these whole numbers. So to get back to my answer, I'm going to need to do the opposite, which is divide by 100. So if I go back to this problem, I'm going to write it as 122 times 8, divide by 100 to get back to my answer. Now, first I'm going to estimate though, to make sure I don't make any mistakes here. I would round 12.2 to about 12. If I had $12.20, I have about $12. And if I have 8/10, that's like saying 80 cents, that's really close to $1. My answer is going to be around 12, probably a little less because I have rounded up to that dollar. So that gives me an idea of about where I need to be. Okay, so I'm going to use my standard algorithm to do 122 times 8. 8 times 2 is 16. I leave my 6 in the ones. I place my 10 in the tens place. 8 times 20, 160. That's 16 tens, and one more 10 is 17 tens. place my 100 over here. 8 times 100 is 800, one more 100 is 976. So 976, and now I need to divide that by 100 to get my final answer. Let's take a look back at our place value chart just to prove that it works. I'm now at 976. I said I need to divide by 100. Okay, so I'm going to go over 2 places, 2 powers of 10 toward the right. So 1, 2, my 6 moves over, 1, 2, my 7 moves over, and 1, 2, my 9 moves over. My answer is 9 76/100. If I look back at my problem here and my estimate, 9 76/100 is close to 12. In fact, we predicted it would be a little bit less. That does make sense from that standpoint, and I came up with my answer. All right, let's look at one more. Another problem that they had in November, 3 5/10 times 76/100. Let's start by estimating. 3 5/10, $3.50. It's right in the middle, but I'm going to round it up to $4. 4 and 76/100, that's like saying 76 cents. That's close to $1. 4 times 1 is 4. Again, I rounded both of those up. I expect my answer to be less than 4 at this point. I also know that this number 76/100 is less than 1. When I multiply a number by less than 1, that's another one of our standards, I know my answer is going to get smaller. So I'm going to put my 3 5/10 here. I want to make it a whole number. How many places do I have to move it over? I have to move it over 1. Each number moves over just 1 place. That is times 10. My other number, 76/100, I want to make it the whole number 76. How many places do I have to move this 7 over? 1, 2 places. Same way with the 6. 1, 2 places to make it a whole number. This one I had to multiply by 100 times 10 times 10. So 10 times 100, I've multiplied these numbers by 1,000. I'm going to need to divide by 1,000 to get back to my actual answer. So 35 times 76, and I will divide by 1,000. Okay, I'm going to use my standard algorithm. 35 times 76. 6 times 5 is 30. Put my 3 tens here. 6 times 3 tens is 18 tens. 3 more tens, 21 tens. I move into my tens place. 7 tens times 5 is 350. I'm going to leave my 5 tens there. Place my 3 hundreds in the hundreds place. 7 times 3 is 21, plus 3 more hundreds. I have 24 hundreds. Add my numbers together. 2,660. Again, if I stopped there, I would know 2,660 and 4 is not very close together. I now need to divide this number by 1,000. 2,660. 1,000 has 3 powers of 10. I need to move it 3 places. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. My answer is 2 and 66/100. Does that make sense? Yes, 2 and 66/100 is closer to 4, and I predicted it would be less, so therefore it makes sense. Now, I know that many of us were taught when we write this out as a standard algorithm, we work it out, and then we count how many places, 1 decimal place, 2 decimal places, that's 3 decimal places, 1, 2, 3. The students will start to see that. This is just helping them understand why it works and how it relates to all the other work that we've done.